So hi everyone, welcome today to this webinar when we're going to talk about building AI agents and with practical example of a demo and also some use cases using Ingest and Render. And so my name is Charlie. I've been a software engineer for 10 years and a tech lead at Algolia. Then I've been a YC founder building a dev tool and now working as developer marketer at Ingest. And with me today is Jess.
Hey, I'm Jess, and I'm a developer advocate at Render. And just like Charlie, I was a software engineer for 10 years before this. And I worked at everything from a 5-person startup that's now a unicorn to Meta when it was just 4,000 to 10,000 people. So I've seen all of these, the scale of very different tech companies, and that's the experience I bring to my work at Render. All right, as a quick intro, today our goal is to help you understand AI agents and see what it takes to implement one. So we're going to show you the code level of even our Hacker News agent that we've built. And then we want you to leave feeling really confident in being able to deploy an agent to production on Render and Ingest. So feel free at any time to post any questions in the comments, by the way, and we will answer them probably at the end, but any relevant ones in the middle as well. So today I'm gonna start with an intro to AI agents. Then we're gonna show you the deep dive into the Hacker News agent. We'll talk about an actual production AI app called Faye that uses both ingest and render. And then we'll talk about moving our apps to production. All right, and I'll just jump in. So as a quick intro to agents, I'm actually going to back up a little bit and just talk about the 3-act sort of story of AI apps so far. So the first act was chat apps. You've probably seen ChatGPT. You say something, it says something back, very simple. And there are some real problems, like restrictions. First, it doesn't really know anything about your data, your company. It'll tend to hallucinate those things. It also has a cutoff date for the amount of information it has about the world. So as a response to this, the next sort of act, you've probably even heard of this, RAG, which is the idea of adding your data to this basic chat app. So before you send that query to an LLM, you send additional data about your specific domain that is relevant to the question that's being asked. And then you get a better answer back. And this is actually an example of one of the first AI workflows that emerged that people found really successful. And this actually takes us to agents today. So agents, what are they? There's actually so many different it could mean so many things. So we will actually leave you with this one definition though, which is an agent is some app where the LLM determines program flow. And so it's making some decision that actually is more than just answering a query you give it. And to go further into this, there's a really useful framework that Hugging Face has created, and it's called levels of agency. So sort of level 0 is the LLM doesn't affect control flow at all. We get to level 1, which is it's basically an if-else router. And then it gets more interesting at level 2. So at this point, the LLM is doing something called a tool call. So tools are something you're going to see in our Hacker News app today. It basically is an additional piece of functionality that the LLM can reach outside of itself and say, I want to do this action, right? It could be as open-ended as making an HTTP request, but it usually will be something that is much more specific to your problem, and you can actually write these tools yourself in code, and you'll see that today. At the most advanced levels, the LLM, like at level 3, is actually determining when to end this program and sort of what paths to take, and it could even kick off another agent. Now, this is still kind of high level, so we have an additional sort of framework to point you towards. So Anthropic wrote a post called Building Effective Agents back in December, and they've highlighted many different architectures that are used to create AI agents. And they actually have slightly different definitions than the Hugging Face model. They break things down into something they call workflows and then like real autonomous agents. So for workflows, I'm just going to highlight two. There's a lot more in the actual blog post. So the first one I'll highlight is called prompt chaining. And this is basically just calling LLMs one at a time, right? It could be one call to generate text, then the next call will translate that text. So it's not, there's no impact on the control flow here. That program, step one, step two, has been predetermined. But then the next example we'll look at, it's called routing. So here the LLM actually acts as a router. So this could be like a customer support type of, hey, which type of support question is this? And the LLM decides and then calls a further LLM based on the type. So this is actually now controlling the program flow. And that's, in the Hugging Face definition would be a level of agency. So yeah, the last example here is this is actually what Anthropic calls an agent. And this is sort of the level 3 in the Hugging Face model, where you're actually having the LLM determine actions like tool calls and then deciding whether to continue based on the feedback from the environment and possibly from the human as well. All right, so now that we have this really framework so you understand what we're talking about in terms of agents, we're now actually going to take a look at a very specific example that we built, the Hacker News agent. And Charlie will kick us off.
Yeah, thank you, Jess. So now let's take a look at a concrete example, like a demo that's called Hacker News agent. So this is our Hacker News agent. So we've built this demo agent that's going to help us to stay on top of the news on Hacker News. And so what you can do is define some area of interest. So for example, AI agents. You can enter a question and a frequency at which the agent will have to answer this question given of the new data it's going to fetch, And here, for example, we want to know every day what are the latest stories about AI agents. So this is the use case we're going to look at today, and we're going to see how we implemented that and how it actually fits into the different scales that we just saw, the Hugging Face level of agency, but also the unthroughput definition. So here you can see, for example, like the email that's been received in my inbox that sums up like every day the different launches and everything. So it's actually pretty useful on my side, and I think on your side too, Jess, right? So first, before digging into like the code and looking at the architecture and everything, let's ask ourselves when to build an agent. So question to ask yourself, this is kind of the AI agent checklist. AI agents in the wide sense of it, which is like from workflow to fully autonomous one. The first one is like compared to actual program you can actually write, with like fixed steps that doesn't use AI. Is it benefit from having like AI if the goal is dynamic? Yes, of course. If the goal that you have to achieve, is different from every time you run the program, then having some AI, try to understand the goal and change maybe the workflow and have some kind of like reasoning is going to help. Also, having to handle like some kind of unstructured data, which is exactly what we have with these Arcanine agents, is helping a lot, trying to understand, like the data and everything. Again, like a last thing is a very good example is like if AI is going to help you and developing an AI agent is going to help you actually to automate some human tasks. So let's see how our Arcanine agent, fit to those questions. The first, is the goal dynamic? Yes, because here we're going to have to answer pretty vague or like kind of like dynamic questions, like what are the latest tool launched? And secondly, our agent will have to operate over like kind of unstructured and super differentiated, diverse information, because I can usually can have like, I don't know, quantum computing, but also AI, but also like Next.js dev tools. So you have to have this kind of like comprehension and reasoning in the way it works. And finally, the good reason is like it actually replace a human, because this is something like personally I'm doing manually, and having this kind of agent is saving a lot of time. So now that we kind of saw, like the agent we're going to look at, and also why we choose to do it and why it's a good fit for an AI agent, let's take a look at the architecture, the high level, and then we jump into the code. And I'm gonna head back to Jess that's gonna show you the architecture.
Thanks, Charlie. So for the architecture overview, first I'll talk about the different components of our app. And it's actually pretty simple under the hood. We only have three major components. The first is our Postgres database. And we'll dig into this a bit more, but this stores sort of our Hacker News stories as well as our configurations, like the email addresses and topics. Then we have our cron job here, which is going to fetch Hacker News stories and put it in our database. And finally, we have our web service, which both hosts the UI as well as the agent AI workflow. So let's take a look at each of these in more detail. Before we do that, I will point out that all of this infra runs on Render, and that is the database, cron job, and web service. So where does ingest come in? Next slide. Ingest is orchestrating the AI workflow. And also it's providing a framework called the agent kit, which lets us easily define all of the steps and logic in our AI agent. So we're going to see the code later. Charlie's going to dive into it. But the idea of ingest in general is that ingest will let you durably execute a workflow that has many steps. So in our agent, we have several steps. First, we got to search for similar stories to the ones that match our topic in question. And then we have to summarize, and then we need to send the email. So those things are things that we can ask ingest to make sure they always run in order, and any retries or failures are handled by ingest as well. So that takes a lot of our systems programming problems away. All right, let's take a look at the individual components now. So the database is a Postgres database with PG Vector, which is an open source extension for Postgres. We make it really easy to add this to any Postgres database on Render. And the great thing about it is it kind of turns your database into a vector database. So as we mentioned, we store your configs in this database. That's not so interesting. You've probably seen this before, like email address to topic and what questions you have. The interesting part is in the Hacker News stories that we also store. And this table here, this create statement, shows you how we actually define this table. And so you can see we store the title, the content in usual text. We also store this field called embedding, and that's a vector type. And that vector type comes from PG Vector. And embeddings, if you haven't heard of them, they're basically a representation of text that is used a lot in these Gen AI models. It basically kind of distills down your text so that it gets at sort of semantically what does it mean, right? And so I can compare two embeddings and decide if they're semantically kind of talking about the same thing. Not just if they have the same text, right? So that makes it really easy for us to then do things like, hey, find me a story that matches my topic. So the index here that you see is kind of like similar to some other index that you might see in a database to increase performance. This function, HNSW, is actually provided by PG Vector as well. And basically adding this index makes it more efficient for us to go look into all of our stories and then match that up with a topic and question that we're trying to find matches for. So yeah, that's our database. It's actually pretty simple. So next, this is the indexer. So we have a cron job that runs every hour, and it basically, the job is to grab stories that match the topics that we are interested in and then puts them into the database. So this isn't AI yet. It's actually quite a straightforward thing. I will point out we use Playwright to to actually do the web scraping. So there might be something interesting for you to look there if you want to get into the code later. The idea here, though, is that the indexer actually could be transformed into an AI agent if we want to do things like intelligently adjust the frequency of the cron job or how often we're pulling certain topics, or if you wanted to improve the reliability of scraping. So like if the website changes and we want to auto detect that and do something really smart, that could be somewhere where we add agentic abilities. All right, so we're now on to the interesting, the AI agent. We actually built both of the agent workflow and the UI into one Next.js app, which is deployed on Render as a web service. So the UI is going to be something, again, very traditional software engineering. You put in some settings, we store those in the database, you can update things. Now, the interesting part we want to talk about is the backend. So, so this is where we are defining the AI agent logic. This is all in the sort of backend, so to speak, of this web service. And this is where I'm actually going to hand it over to Charlie to dive into all of the code. Oh yeah, so one last thing. Before we dive into the code, I do want to show you how simple this all looks in the Render dashboard. So this is our deployment today, and you can just see there's the three components. There's the database, there is the web service called the Agent Kit Render tutorial, and we have the cron job. And just to show you how easy it is to configure the service, let's take a look at the settings for this one web service. So you can see that we've given, we've picked a region, the instance type. In the build and deploy section, we've hooked this up into our GitHub. And if we just do that, we can auto deploy any changes that we commit to this repo. And then we set the root directory because we have a lot of different components in here. So this is just in the app directory. And we simply specify our build command. So it's like pm build and our start command, which is pm start. So it's that easy to make a new web service spin up on Render. If we look at the environment variables as well on the left-hand side, we can see that's really easy to configure any environment variables we want to set. This includes our database URL, so it can connect to our Render database, as well as our API keys. So yeah, that's a quick overview of what this looks like in Render. All right, Charlie, you want to show us the code?
Yeah. So now that we have a good understanding of what part I'm running where, we're going to take a look at this Next.js app and especially at the agent itself. But before jumping into the code, we have to take a look at some concepts. Because like Jess said, everything that's in most of the agent is running using Agent Kit. So Agent Kit is an AI layer kind of library in TypeScript that can be used with ingest to define different parts that the agent is going to need to work. And the agent is composed of small agents that are wrappers around LLM calls that can be coupled with tools. So for example, if you want to do like a search, you can also provide some like search tool to actually query the embedding and provide them to the LLM so it actually can format, or dynamically call those tools, which is called tool calling or tool use is with Anthropic. And finally, once you have those agents defined, you can put them in a network, and the network is where the magic is going to happen. It's the network that's going to orchestrate all those agents to create this agentic behavior that defines, the AI agent, what we talked about from level 2 to level 3 in the Hugging Face level of agency. So enough theoretical stuff, and let's look at the code. It's going to be easier to understand. So this is our Next.js application, and this is actually the repo you can access, and you'll find the link at the end. Everything is open source and available and ready to deploy on Render. So you're going to have two packages, the indexer and the app, which is Next.js app. I'm not going to cover the indexer because, like Jess said, it's a cron doing some playwright scrapping with some embeddings and stuff. But if you're curious, you can take a look definitely. So first, what we're going to do is we're going to look at the actual workflows that runs our agentic part of our AI agents. And the first thing that we do, with ingest is actually create a function inside of our Next.js application. It can also be inside of a, inside of a Python application or other type of TypeScript application. So when you create a function, you're going to give it a name, and this we're going to see as helpful in the actual ingest UI, to identify different functions. An ingest function is going to be triggered by an event. So here, this is the name of the event. And later, I'm going to show you how this works. We saw a video earlier when you click on preview, we get a live preview running of what's the email is going to look like, on the configured frequency. We're going to see how the event is going to be triggered. Then, this is the actual handler of a function. So this is the code of our ingest workflow. That's going to receive an event, a DB connection, and some step tools. So we're going to see what is it. The event is going to carry some information. So here, the thing that we need is the interest ID. So for example, it's going to be the ID pointing to developer tools and the question ID pointing to what are the latest launches. And then with ingest, you can define workflows. So first, ingest is a workflow engine. So you can define workflows with different steps. Each steps is a atomic part of your workflow that can be retried independently and that benefits from caching. So this thing means that, for example, like if we run multiple steps and the last one is failing, your function and your workflow is going to rerun without rerunning the different step that already successfully executed before. So this is one of the main, advantage of using ingest, especially in AI application, because without having to rerun, successful step, you are saving on tokens, you are saving on performance, global experience, and everything. So first thing that we need to do before actually running the agenting part of our agent is actually to fetch the data. So from the IDs, we're going to fetch the full objects, so the interest, the name of the interest, so developer tools, and the actual full question. If there is no interest of question, it means that basically the actual interest or question has been deleted since the last occurrence of the frequency. So if you have something that is scheduled every week and that since the last run you actually deleted this question, then basically this run is going to auto-cancel by just returning and stopping the execution. Here, this is where we enter in the kind of like reasoning and interesting part of the technical overview. So, like just earlier, I described the fact that using AgentKit, you can define agent, a network, and then you have some tools and some things that helps you to bring some reasoning inside of your AI workflows and to kind of like climb this level of agency that Hugging Face are defining. So this is where it's happening, and this is what we're going to spend most of our time looking at. Just fast forward, let's say that the actual like network of agents ran successfully and return some actual answer to the question of the given interest. Then we have some results that have been put in the state of the network. I'll talk about that. And then if we have some answers and we are not running in preview, so if it has been run as a schedule and not as a preview from the UI, then we want to send an email. And then if it's not a preview, we want to reschedule it by sending an event with a new timestamp that's going to match the next occurrence. So this is more like the actual overview of the whole workflow. Let's now take a look at the definition of an AI agent. So as we saw, our agent is responsible of taking a question and given embeddings that are stored in the vector database, which are like Arcanum stories, has to answer the question and find the best stories that match this question. So the first thing we're going to do is actually to look at the search agent. So with AgentKit, you're going to define agents that are going to be orchestrated by a network to work together to answer an input. So here we can see that an agent has a name and has a description. So this is going to be helpful for the network. So when the network is running with a LLM router, so a router that is using an LLM to actually choose the next agent to run, is going to use the description and the name of the agent to choose the best fit depending on the actual question to answer and the state of the actual run. Here we have a system prompt. So it's, if you're familiar with AI, it's a system prompt. So like there is like a system prompt, user prompt. So this is going to define the actual, behavior and instruction, for this agent. So this one is a search agent, that is meant to search on Arcanews. And if you played already with agents, you know that you have to provide some very specific stuff because dates can be very confusing for agents. Because like Jess said earlier, some of those have data that are actually dating from like 2023. So if you don't say today is actually 2025, February 4th, 2025, and you say, oh, I want the search, I want to have some answer on things that were posted this week, the agent is going to look for something that maybe happened in 2023. So this is a very important part. Then we're going to say, hey, you are actually searching for posts from the last, and then we're going to translate the frequency, weekly, daily, monthly, to a relative human sentence, word. So this is the first thing with the agent. A very simple agent that doesn't have any kind of like other properties is going to be basically an LLM call, with like maybe a dynamic system prompt. What's interesting here is that our search agent got two tools. And tools, if you're familiar with tool calling, is actually providing to a LLM some tools to use that could be helpful to actually answer the question. So here we are saying, to the search agent, hey, you are searching for news on Arc News, and you have two tools at your disposal. The first one is a search tool, and another one is a trend tool. And what's interesting here, is that those tools, are going to be incorporated in the prompt of the agent automatically. And here, the kind of agentic and reasoning stuff that is happening is that this agent is going to use the tools to find the most relevant stories. And here we are, providing the frequency and the date because the LLM, is going to generate the parameters of the tool on the fly to actually call it. So, for example, if we say, what are the latest developer tools that have been launched this week? Most likely, it's going to call the trends tool because it's more like a trend question. And it's going to call it with the query developer tools launches, start date, Monday 3rd, and end date, it's going to be like today. But let's say to run on Friday, it's going to be Friday day. So this is where tool calling becomes like very interesting. And this is the level 2 of the actual like Hugging Face level of agency, allowing a LLM to actually choose dynamically which tool to call to actually answer a given question. So here we are providing two things that are leveraging the embeddings. So first, we're going to quickly look at that. We're going to do an embedding of the query. Then we're going to do a vector query in SQL, to actually compute actually the stories that are close to this search vector. And then we're going to format the results with the title, content, everything, and we're going to put them in the state of the network. So this is a very important part. So having tools is not only providing external context to the agent and the LLM that is used underneath, but also allowing it, to actually store and share information with other agents that are part of the network. So here, when there are search results, we're going to store them in the state, and we're going to see right after that it's really useful because the summarizer agent is going to use it to create its prompt. So here we have the summarizer agent. This one is going to be called once there is some search result inside of the state of the network. So this is a summarizer agent. Its goal is to summarize the results. And here, a particular interesting thing is the system prompt of this agent is dynamic. It's a function that's going to be called every time to get dynamically define the system prompt. And here we are finding again that this prompt of the summarizer agent is using the state of the network to get either the search result and the trend result, or the trend result. Here, for people that are familiar with the prompting and doing agent, with Anthropic you can use XML, and it also works super well with OpenAI to have this kind of like structured output, working in an agentic way. So here, basically, we are providing the question, the interest, and we say, context plus additional context from the other agent, so from another LLM. So some of you might say it's prompt chaining. It's not really prompt chaining because we're going to see the difference when it comes to definition of the network. Here, an interesting thing also in terms of API with agent. So with AgentKit, you can define lifecycle that allows you to run specific arbitrary code depending on the different stage of the lifecycle of an agent. So it can be before the prompt, before performing the LLM call, after the call. So here, once the LLM call is done, we want to get the result and we want to store it in the state of the network so we can reuse it, at the end to provide the result. Because as a reminder, here, this is what we do. Once it's done, we look at the actual state of the network and we fetch back the answer that has been extracted. So to sum up, we have two agents into our agent kit network. The first one is the search agent that has two tools. It can either try to find Hacker News Story as a search, or it can try to find cluster of topics that are close to each other and to answer the question. Then once it has either search result or trend result, it puts them in the state. And the summarizer agent is going to use this state to create a summary, a comprehensive summary to the given question with the provided result in the state. So let's take a look how we assemble all that, to make it work together and create this network of agents. So here we are creating a network of agents. It has to have a name. We have to assign some agent, also a model. So if you provide a model to the network, this model is going to be used by agent themselves, So here it's running with OpenAI. You can also use Gemini. You can use Anthropic. We support multiple version of model, and you can also use OpenAI compliant API such as self-hosted DeepSeek L1 model. Here we're going to look at that after, but the interesting part of our agent and what makes it like a agent more than a workflow is the fact that the routing and the different link between the LLM calls is defined by the result of the LLMs. Okay, so we saw that, for example, the search agent is putting some results, in the state, and we see here that the router that's going to be called at each iteration, each step of the network, if we have some result in the state, is going to return the summarizer agent and ask the network to execute the summarizer agent. If we have answers, it means that the summarizer agent had an answer and has been run and actually provide an answer and find some answer. Then we can call return, and this is going to stop the network, which finish, the network and return the result here. What's interesting here is that by default, AgentKit provides what we call a routing agent. And a routing agent is a mix of a router and an agent. It's an agent that is used to actually route the other agents. So what it means technically, it means that we actually, when we call this function, we actually call an LLM and say, hey, those are the agents that are defined in our network. This is the state. You have to choose what is the next one to run. So here you can see, looking at the different condition block, that there is no condition to tell who has to be the first agent to run. So the first agent is going to be 99% of the time the search agent, but it's an LLM that's going to determine that the first one that has to be called is the search agent. And relying on this kind of catch-all clause, which is if it doesn't match the actual static workflow that we have in place, we let the LLM choose, enables us to have this kind of flexible behavior. For example, to handle the use case when there is nothing. Sometimes you can say you run the agent on a daily basis and there is nothing on Hacker News. So how do you handle that? Do you do dozens of different ifs and else, to say, oh, if there is nothing, then have to handle it, I have to stop the network, etc. No, just you can let the LLM, look at what's happening and decide what needs to be done, whenever it has to choose another agent or it has to stop. So this is the definition, and this is the overview of how it works. So let's have a demo, a live demo of an agent. Okay, so this is the agent deployed on Render. If I'm clicking on preview here, what's going to happen? So it's going to run the agent, the ingest workflow, which contains the agent kit part. Here on ingest, you're going to see that the workflow is starting to run, and you see the different steps. Okay, so this is due to the fact that here there is a route, that is a preview route, and when you actually request a preview, there is an ingest event that is being sent with the interest ID, question ID, and preview true, which trigger the ingest workflow that we saw here to run, which also trigger the agent kit part, which is the most agentic part of our workflow to run. Then here you can see the different steps. So here we can see that we have a run that is ongoing, and here we can see the routing agent. So when I said that by default, it's an LLM that's going to choose what's the first agent to run. Here, you're going to see that the UI, when it comes to LLM calls, is a bit specific. We have tracking of token, we can see the type of model that's been used, and here we can see the prompt that has been sent to the LLM saying like, hey, you have those agents that are defined, and their description, you have to choose which agent to call. And then the LLM say, okay, so I want to call the search agent. And here you see the search agent that's been run. So here with ingest, you can see live, the input and output of everything that's happening. And see here, when I was talking about tool calling, or search agent decided to go for a search and decide to dynamically, build this argument, which is called like tool calling, by saying, hey, I want to search in a DB, in the vector DB for developer tools from like yesterday to today. So exactly what I explained earlier. Yeah, and that's it. Then when it's run, it's complete, and you can see here it's complete. Okay, so here it's already timeout, but here you can see that the final answer is this one, which is very close to actually what we've shown previously. So now that we saw the actual implementation, let's compare
Charlie,
this Arcane use agent to the level of agency that we saw with Hugging Face. So on the anthropic definition, this is a workflow, because not everything is autonomously decided by the LLM. We still have some kind of like safety measure, if I can say, when we have like part of the workflow that is static, depending of actual LLM calls, and part of it, this is autonomous. But on the Hugging Face level of agency, this is the level 3, where LLM control the iteration and the control flow. So LLM control the iteration because the iteration are based on the different result of the different agents, depending on what the search agent is going to actually put in the state. And same for the summarizer agent, the workflow is not going to be the same, right? So we could ask ourselves, as a kind of like open technical question, what would it take to actually take our Arcanine agent to a fully, autonomous agent as Anthropic defined it, and a level 3 plus. What we could do is to have our agent to have another agent inside that would be like a explorer that would expand some research and do some live scrapping on specific search results to try to provide a better answer. And like Jess said earlier, we could also decide to actually add a fully autonomous agent on the indexer part that would be, like AI-based broader scrapping, but also like auto-scheduling in time. Okay, so I hope you enjoyed this technical preview. Let's now take a look at a real use case of a joint customer of Inngest and Render, Faye, that Jess is going to present you.
Yeah, and I also see that we have some questions coming in. Maybe since there are a good number of them, we will leave them for the end. So stay tuned. But yeah, Charlie just showed you the nuts and bolts of our Hacker News agent. And now I would like to share a little bit about actually a real AI-powered finance app that is running on Inngest and Render today. They're called Faye. And at high level, they are a resource for every individual investor to keep up to date on news and other statistics that might affect your investing plans. So here you can see the dashboard, and they have notably a couple of AI features. So on the AI feature side, next slide, they have summaries of news that might be relevant to things moving in the markets. They summarize SEC filings for you, so they're a lot easier to read. And they send a custom Monday morning email that sounds awfully familiar right now after we've gone through that Hacker News agent example. And their email is customized to whatever your portfolio contains in your dashboard, whatever you're tracking. So their app actually used to run on Google Cloud using GKE, Kubernetes Engine, as well as Cloud Composer. And they last year decided to move to Render and Adjust and actually save $60,000 a year in that process. So we're going to look a little bit under the hood. How do they actually get these savings? And the lessons here are actually relevant to any AI agent app that you're going to deploy. So they found that actually they're, on both the Kubernetes engine and Cloud Composer, they could not understand their build. It was just very hard to understand like where are costs going. And specifically for like deploying services, they found very basic configs, like how do I set up environment variables to be it took a lot of research to figure out. In terms of Cloud Composer, which is sort of built on top of Airflow, if you've heard of that, they found their data pipelines were hard to configure, and they weren't building the most optimal pipelines as a result. They basically said we're really product focused, and we don't want to spend time managing our infra. We want to be shipping features fast. So they moved to Render and Ingest and got two big wins. First was a lot of the savings came from using the right amount of infrastructure. So they had over provision actually on Google Kubernetes engine. And on Render, they, as you saw on the dashboard earlier, it's really easy to say, hey, I just want this one web service. Here's what I'm deploying. I'll show you later some of the features we let you, auto scale and determine very specific configurations very easily to get sort of the benefits of Kubernetes without having to configure Kubernetes yourself. So actually, Dennis here, he's the CTO, said that it took days and weeks to set up on GCP, and it took him 2 to 3 hours to move everything over to Render. So the second win for them was actually on the ingest side. They improved their data jobs. They actually got better performance and saved money. So they used to just run daily jobs on Cloud Composer, and with the abstractions that Ingest provided, so the sort of steps that are tied together by workflow, they're very easily able to architect their jobs to run only when new data is available. So that means they're able to be more responsive, but also save on unnecessary jobs, or they're not running those anymore. So those are the two biggest wins. The overall story for them, though, is that they weren't just optimizing costs. They're really trying to move faster. And they said, yeah, we chose these tools, and like what actually mattered was we wanted developer experience gains, right? We could have further optimized our costs, but we actually wanted to get the best tool set for our team to be very product focused. So yeah, I think these lessons translate a lot to anything you want to deploy and any products you want to build as well. So yeah, next we're going to talk about, we've just seen this example of a real app that's running agents in the background. We've seen our tutorial, and let's talk about what it might take to bring this Hacker News agent to production. So first, I will talk about sort of the render considerations. And actually, before even diving in, I'll say we're going to focus on the database and the web service in particular, because that's where we're more likely to see some scaling challenges as more agents, workflows are running, and more data is coming into the database. So we'll highlight those two. So first, let's talk about the database. Now, with databases, you've probably heard a lot about these different types of things to worry about, like scale, right? Having read replicas, having point-in-time recovery, so the ability to roll back your database to any time in the past. I won't go through every single thing on the slide, but I will highlight two that might be somewhat newer to you. So first is high availability. This is something that Render makes as easy as like sort of checking a checkbox on your dashboard. Basically, Render can set up a secondary standby instance of your database and keep that up to date. And if ever there's a problem connecting to your main database, Render will automatically fail over to the standby and make that the primary. So that's something that's just super easy, comes out of the box, no work for you on the infra side. The second thing I'll highlight is our private networking, which is available on every single tier of Render, including the sort of hobby tier. So basically, you've probably had that experience of standing up a database on somewhere on some managed database somewhere. You just connect to it from your terminal locally. That's great, like when you're you want to just allow list your one IP, but you don't generally want your database exposed to the open internet. So like if anybody has your password, they can kind of get into your database. That's still not super safe. So Render actually lets you run your services and communicate with between your web services and your Postgres databases and other services on a private network. So that traffic never leaves Render's network, and it's protected from the open internet. And that is something that's not specific to databases, but that's something you can take advantage of when you are configuring your web services and databases. So yeah, next let's talk about web services. So probably one of the most obvious things you will think about is, hey, scaling, right? How do I scale horizontally if I get a burst of traffic or something? So Render makes it really easy to auto scale your web services. This is literally the configuration that you'll see in the UI. So you can just like turn on auto scaling and then set the minimum and maximum number of instances you want, and then set target CPU and memory utilization breakpoints for when we will create a new instance or spin down other instances. So that makes it really, really easy. This is sort of like the power of Kubernetes without all of the infra setup. Secondly, we also recognize that it's really important to keep an eye on the health of your services. So out of the box, we give you a good number of dashboards. We even break it down by the instances. So you can see here, like the two colors here are like the CPU by instance. And then finally, when you're in production, you're probably working with a team. You want to work well and remove any friction that's sort of involved in the day-to-day of getting new changes out. So this is where Render's DX really shines. And some things I'll just highlight. You can easily just create auto deploys based on connected directly to your Git repo. So anytime you commit a change, it will trigger a deploy of your app. You can turn that off. You don't want to do that. You can also create preview environments that let you basically spin up an entire version of your app. And so you can like test it even against a test database. And all of that happens before you even commit your Git change. So you can do that before and be sure that your change is going to be not problematic. But also we make it easy to do things like one click to roll back. You can specify your infrastructure as code. If you know that, if you've ever heard of Terraform, we have a much easier to understand version of that for Render. And those are just some of the things that we make really, really easy.
On the ingest side, when it comes to the AI agent web service and the AI agent part and any kind of workflows, so moving from like something, for example, that we deploy for the both of us with Jess, and something you want to deploy to maybe a team of 100 people, like publicly, as a app, is very different because the workflow is bound, to external like kind of like constraints and also dependency, such like rate limiting and kind of like costly APIs. So of course, what you want to put in place is kind of like concurrency and throttling that you can add to your AI agent and AI workflows just by a one-liner in the function definition that we saw earlier. And also, I would like to cover like the multi-tenancy, so there is a global concurrency and throttling vehicles. So you can also like create dynamics one, where you can have like throttling and concurrency that is bound to a specific user or a team, which gives you like multi-tenancy in one line of code. And multi-tenancy avoids you to fail into like the noisy neighborhood kind of problem, which is like you have like 100 of users, but one is going to use so much, resources and make so much requests or have so much like question defined and stuff that it's going to use like more resources and it's going to degrade like the experience of other users. So this is where multi-tenancy is useful, and achieving such thing and such kind of like normally complicated design is super easy with ingest. We saw you have like automatic cached retries that are pretty helpful, when you're working with a lot of tools, when you're adding more level, of uncertainty and like kind of reasoning to your agent, it can fail, and you can retry it and keep the context and have persisted like state of your network and everything. Talking about tools, we are going to ship this week the parallelism support for tools. So when your agent want to call multiple tools, it's not going to be done parallel like in the TypeScript or like other languages way. It's going to be done in parallel, like in the ingest way, which is bound to the actual infrastructure underneath. So every parallel tool call is going to be in its own, defined step that can retry and stuff. So it's another level of scaling. And again, this is achievable, but just like one-liner using promise.all. One example about that, in our like agent kit documentation are available. All that is running, with the ingest infrastructure that is currently, processing over 1 billion runs, even more than that. Like I think it's close to 2 billion now runs per month and growing. On the right, you can see, and as I shown, live, the observability is top notch because you have first the actual like observability that we have for any kind of workflow, which is fine-grained at the step level, where you can see like, the different timings and different things that are happening like in live. But also we have this AI layer that gives you like the number of tokens, the comparison of input and output. I didn't have time to show that, but you can also like update the input and rerun a specific step only and rerun your workflow from this step, but changing the actual prompt and restarting it from point in time. So it's pretty powerful, and we also plan to revamp this UI very soon to make it easier to use with large prompts, which happen very often, with agents. And finally, is the deployment DX. So like Render, infrastructure is complicated, and especially the deployment and setting up everything. So we are making things easier, with like concurrency throttling, but not only. Ingest is local first. So you can start to work locally because it's open source, run it locally, connect to your external point, to your render Postgres vector database. And then you can move to production, by actually switching to the private network, deploying it directly from your Git, connected with Render directly with preview environment support, which means that if you have pull requests, you can also have like different version of your ingest app that matches your actually preview environment on Render. So all that allows you to move fast, not lose time, on like setting up the infrastructure, setting up like different like scaling rules, like concurrency throttling and everything, and ship AI pretty fast.
So that's it. Thanks for coming to hear all about AI agents with us. We have a page for all of the resources that you might have seen if you caught part of this, or we have, go to this page now, basically render.com, AI agents ingest render. We actually are offering office hours for people who are here, and you can chat with us for 10 or 15 minutes for any questions about getting on Render or Ingest. You'll get the recording once we have it up, and there's a full tutorial to deploy the agent that we talked about today. So I know we had some questions about, are we going to get the code? There's not only the code, there's a whole blog post that explains all the details in case you want to review. Actually, we also have some questions that are in the channel. Let's take them now.
Yeah, and we have like a few minutes, so let's step them from top to bottom. So recording and source code. Yes. Thank you, Brandon. So how long does the network state live? Is it contextual to the session, time-based, or something else? So right now, the network state lives for the duration of the workflow. So there is no like automatic persistence, but you can definitely, provide when you start the network an existing state. So you could use the render Postgres to actually persist the state across multiple runs, and then in this way implement memory kinda. Thank you, Bram. Brendan, feel free to follow up if you have a follow-up question on that. Winston had the question: is the routing agent distinct from the LLM you interface within on the app? I think there was like, oh no, okay, sorry. There is another question from Brendan first. Can you specify a different model for each agent? If not, can multiple network interact with each other, assuming the model is tied to network? So no. So here, for example, I could say, for example, that the model is actually anthropic and that it's a anthropic model. And yeah. Yep. So I can do, okay, he's not happy because this is not the latest. This is going to work, I think. Anyway, yeah, I need to provide the max token. Sorry. Yeah, so here I can say that the search agent is running on Anthropic and that the summarizer agent is using Gemini, and that then what's going to happen is that the OpenAI agent is only going to be used for the routing agent. So the default model is used by the default routing agent and by the agent that doesn't actually specify a model. And I think this also answers the question of Winston, if I understand it properly. So is the routing agent distinct from the LLM you interface with on the app? I'm not sure I understand this question. I'm going to try to answer it in two different ways. So if the question is like, is it linked to the actual default model? Yes. So I just explained it. Like the default model is going to be used by all the agents, that are like that doesn't provide a model and the default routing agent. So this is the first possible answer. The second one, yeah, so the routing agent is distinct. Okay, so the routing agent that you provide as a router is not going to be listed as the agent of the network. It's a distinct entity. It's not the same type of agent. And we might maybe change the naming to make it clear. I don't know if there is others questions. Yeah, so I guess we can post the. So normally you will find the repo link on this page. I'm not sure, Jess, or if
Oh,
it's
we link to yeah, I can add that. So we link to the blog post, which links to the repo right
okay.
now. But we can also post
Oh,
the repo link directly. I'll add
yeah, we
that.
can post it on LinkedIn. We'll do right after we after the stream. We had it on LinkedIn. I don't know. We can give one more minute maybe for like other questions. Is that something else you'd like to suggest? Or maybe no. Okay.
Thanks everyone for
Yeah.
coming.
Yeah, thank you everyone. We hope it was interesting. You learned a lot of things today. Again, the recording will be available soon, as soon as possible. You'll find it on this page that is displayed right now, the URL. You can access the free tutorial. And again, if you have any question, on Render or Ingest or the both of them, to use them to actually build AI applications and even better AI agents, you'll find some links on this page to actually book some call with us, some office hour to brainstorm with you about your technical use cases and everything.
Yeah.
Okay.
And we mentioned also the GitHub repo that we've linked has very detailed instructions on how to deploy the agent. So that's all going to be in the README. We didn't cover that step by step, but every single step is in that README.
Yep, that's true. Okay, thank you everyone. Thank you, Winston. Thank you, Brendan. Thank you, Bram. It was great having you all here. We had a lot of fun. It was a lot of fun to build this demo and actually to also do the presentation. And yeah, see you for the next one.
Bye, everyone.
Bye.